probably think you've got diffusion completely figured out, right? But here's the reality. The Agar block experiment is exactly where Cambridge Biology 9700 candidates consistently throw away super easy marks. So this explainer is your ultimate no-fluff guide to absolutely mastering topic 4.2, the effect of surface area to volume ratio on diffusion using Agar blocks. We're going to completely deconstruct exactly what the examiners are actually looking for, so you never lose these crucial marks ever again. Let's get into it.
So why do students consistently lose critical method marks on Agar block questions? Honestly, it's a fatal error that costs you a whole grade boundary before you even realize you're making a mistake. Picture this. You sit down in the exam, you see that familiar setup with agar blocks, phenolphthalein, and some acid, and you immediately just start scribbling down generic facts about surface area. But stop right there. You are falling into a massive trap.
And this brilliantly illustrates exactly what I mean. Look at the flawed student answer, relying on generic diffusion terms, compared to the top band examiner answer. The big difference here? That top band answer uses precise, context-specific terminology. See, ordinary revision fails here because just memorizing the textbook definition of diffusion, it's not enough. You absolutely have to apply the concept to the specific, unfamiliar context provided in the stimulus material.
To make sure you lock in those top-tier marks, we're going to use a master framework today. We'll cover H. 1. The fatal exam mistake. 2. Essay-vol ratio core principles. 3. The Agar block methodology. 4. Winning critical data interpretation. And 5. Evading top examiner traps. This isn't just some boring list. It's literally the exact analytical framework that will make the examiner's clues completely obvious to you. Okay, let's dive into this first section, the fatal exam mistake. What do the principal examiner reports actually reveal? Well, we've analyzed them, and they are incredibly clear about where students are going wrong when handling data and evaluating information for this specific topic. Turns out, there are exactly 3 top mistakes that examiners consistently highlight in their reports for syllabus 9700 regarding Agar blocks. And honestly, if you don't know what these 3 mistakes are, you're essentially gambling with your final grade. The absolute most devastating of those 3 is a classic trap, using the wrong terminology for the wrong context. This is a direct insight straight from the Cambridge Principal Examiner reports. Think about it. If the exam question asks about agar blocks, simulating cells, and you write a generic answer about gas exchange in the alveoli, you get 0. You must apply your precise scientific reasoning to the exact scenario they give you. No exceptions. But hey, there is a specific way to beat this. In just a moment, I'll reveal the missing examiner's clue that changes your answer entirely. It's a technique that literally forces you to use the right context. But first, we need to build the theoretical framework that makes that specific clue obvious. Which brings us to Section 2, SA-Vol ratio core principles and the theoretical architecture. The syllabus clearly emphasizes that to secure those top-tier marks, candidates have got to demonstrate a real mastery of fundamental principles, precise definitions, and causal relationships. So, the absolutely crucial point here is cross-topic connection. The principal examiner reports highlight that top-performing candidates don't just memorize this as some isolated Agar block experiment. No, they take the rules of surface area to volume ratio and apply them effortlessly to completely new scenarios. Integrating causal relationships from essay to vol into other syllabus areas, that is exactly what sets an A-star student apart from a B student. It's a real game changer. Let's move to and see how this builds into practical skills. Section 3, the Agar block methodology and earning method marks. Because earning your method marks requires a really systematic approach to processing these questions. When you're tackling these examination questions, you've got to follow this exact 5-step procedural framework. Step 1, deconstruct the question. Step 2, extract the relevant data. Step 3, select your analytical framework. Step 4, execute with clear notation. And Step 5, present with correct terminology. Now listen closely. If you skip Step 4, that execution phase, you are in serious danger. And that brings us to a massive examiner alert. Students lose marks by not showing working. If your exam paper is just a mess of numbers with no clear steps, you will lose marks. But here's the magic. Method marks can save you even if the final answer is totally wrong. Say you make a silly math error. Under pressure, it happens. Applying the relevant principles and executing the analysis with clear working is how you mitigate that grade boundary risk. Always, always show your working. Now, the stakes escalate even further. We're entering Section 4, winning critical data interpretation. This is the mathematical and statistical side of things, and it's exactly where examiners separate the top band candidates from everyone else. You'll be asked to calculate relevant statistics and draw evidence-based conclusions. Now, what's really interesting about this is how you actually pick your statistical test. In Biology 9700, statistical analysis requires selecting the right tool for the job. You're going to use a t-test for comparing means, you'll use a chi-squared test for categorical data, and you'll use correlation tests for relationships between variables. Knowing exactly which test fits the data extracted from those Agar experiment tables is a totally non-negotiable skill for data interpretation. But beyond just the math, top-scoring candidates demonstrate true evaluative thinking. When you're evaluating the quality of the evidence provided in the exam, you need to systematically analyze these 4 parameters. Identify the limitations of the experiment, question the assumptions being made, consider alternative interpretations of the data, and finally, assess the effect on the conclusions. Basically, justifying your decisions with solid evidence is key here. All of this leads us perfectly into our final phase, Section 5, Evading Top Examiner Traps. We're going to apply everything we've just learned to directly solve the very problems we established at the beginning of this explainer. So, let's take a quick moment to recap those 3 fatal mistakes from the principal examiner reports, just to make absolutely sure they stick with you. Trap 1, using the wrong terminology in the wrong context. Trap 2, forgetting to check your units during calculations. And Trap 3, providing answers that are not specific to the context given. Make it a habit, verify your results, check those units, and anchor your scientific reasoning directly to the Agar blocks they described in the prompt. And finally, here is that missing clue I promised you earlier. When you're asked for a comparative analysis, the absolute secret is using comparative connectives. You must always identify both similarities and differences, support each single comparison with evidence from the data, and draw conclusions about their relative importance. This forces you to use the exact wording and context the examiner wants, and it completely bypasses the trap of giving generic answers. Okay, so you now have the ultimate analytical framework for the Agar block experiment. You know the mistakes, the theoretical architecture, and the secret examiner clues. But what if the command word itself, whether it says explain, describe, or evaluate, is actually the hidden cause of your grade boundary risk? Think about it. Using the right framework with the wrong command word still equals 0 marks. To solve this newly uncovered mystery, you're gonna need our next explainer on command words that decide the mark band. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. See you in the next masterclass.